design a system like YouTube, which is user should be able to upload the video. As we know, YouTube is famous for the videos, correct? And the size of video is huge. So the question comes, where do we store the video? So now that we know we will store the images and videos in the object or the file storage like Amazon S3, but who will upload this to S3? Will it be done by the backend? Now one question may come to your mind is, if we have the video ID, why do we need the upload session ID? Like when we talk about system design, we don't trust client blindly. But here you can see client is given huge amount of responsibility, and all of this process of chunks and uploading directly to file storage is happening through the client. So should we trust the client blindly? Now what is this E tag? So in this way, even if you get a network issue like Wi-Fi was not working, then next time you don't have to upload the video from the beginning. You can simply upload the chunks which are missing. This video upload service will publish an event to Kafka. Now you will say, what? Why to use Kafka here? Now one question when we talk about the pre-signed URL, is it generated by the video upload service or the S3? We said like backend will verify the E tag with the S3 storage, right? So it gets the E tag from client. It will also get it from the S3 storage and verify it. Do we need to do it at that time when we get from the client? Now what is the role of Kafka? Why YouTube needs Kafka? Why not just call services directly from the video upload service? Why are we using Kafka here and why not database? When we talked about uploading process, we said we don't want to go through backend. So we directly uploaded from client to S3, correct? And here we created small chunks. Now here in video processing service also, you are basically creating small segments. So you might think like, what are we doing here? We are doing the same things again and again. Now if we talk about that transcoding part, like who will decide what all resolutions will be present? So in order to avoid that storage on server side, we uploaded directly from client to the S3. Okay, but now we are saying the video processing service will download the large file from the S3. So the same question comes again, like how do we have this capability of storing this much huge amount of files on the server now? How about the aspect ratio? Like in mobile device you have to show differently, whereas when you are using the laptop, the screen is more wider, correct? So how do we manage the aspect ratio? So you have to always remember this point. If there are a lot of write operations or update operations happening, then make sure you are not writing this kind of logic that for each operation you are performing the update or insert operation on DB. If you're doing this, it is not scalable. Your database will go down. Hi, my name is Mohit Chabda, ex-Salesforce, ex-Walmart, and in today's video, we are going to discuss a very famous high-level design question, which is design a system like YouTube. So this video can help you crack your dream company offer. So what I want from you is make sure that you like this video, subscribe to the channel and share it with your friends and family so that I get the motivation to create more such wonderful content for you. Now let's start with the video. So whenever you are asked a high-level design question in the interview, the first step generally is to clarify the requirements. Because the interview round is generally for 1 hour, starting 5 to 7 minutes goes for your introduction and last 5-7 minutes are left for any questions that you have for the interviewer. So you are left with 45 minutes and now you have to design the system in just 45 minutes. Of course, you cannot design the complete system in this small time. So that's why it's really important that you clarify the requirements in the beginning so that you get to know what the interviewer wants you to focus on. We generally pick 2 to 3 important features of the system and then we spend 40 to 45 minutes designing those features. Okay, so let's start with the functional and non-functional requirement for designing YouTube. First, when we talk about the functional requirements, those would be first, uploading the videos. A user should be able to upload the video. And next major functional requirement is user should be able to search and view the video. So these are the two major functional requirements. Apart from that, you can have some optional requirements like user can like or dislike the video and user can comment on the video. These are optional, but these are the major functional requirements. Now talking about the non-functional requirements, as you know, YouTube is a platform where users go and watch the videos. So first non-functional requirement would be the video loading should be very fast. Just imagine if you open a video and it keeps on buffering. It's so irritating and the end user won't use your platform, right? So you need to make sure that the video loading is quite fast. Next, as we are talking about the platform like YouTube, which is famous across the globe, so it should be available all the time. And because a lot of people use YouTube, so it should be able to scale to millions of users. Another important non-functional requirement is, because we have videos on YouTube and the size of video is generally huge. It can be in GBs or even more. So our platform should be able to store huge video files. Another non-functional requirement would be it should be reliable and durable. So if you upload a video today, it should stay there. You can watch that video even after a few weeks, months, or years. Now, in system design interview round, apart from the functional and non-functional requirements, you generally also have to talk about the APIs which are required for this system and the database core entities. Okay, so both of these will be required. What we will do here is, instead of talking directly about the API or entity, we will go to the high level components, and while discussing the components you'll get to know the complete flow, and during that time we'll also discuss some of the APIs and the entities which would be required to design YouTube. Okay, so let's start with the first functional requirement, which is user should be able to upload the video. Okay, so let's start with the high level components. So here you can see I have created few basic components. The first one is the client. Now if you want to know about the basics like what is a client, what is a server, what is a API gateway, load balancer, etc., you can refer to this video of mine where I've talked about all of these basic concepts in detail. But just to summarize things for you, so client is the platform through which the end customer is using your product. So for example, here we are talking about YouTube, correct? So I'm writing here YT. So this is your product. Now just think, how does the end user use this product? Generally, they would use it on the mobile device, correct? The mobile can be your iPhone or Android device. Inside the phone you generally have the YouTube application, and when you open the YouTube application, through that you can use this platform, correct? One more medium is like on the personal computer you can use the web browser, correct? And in the web browser you can type www.youtube.com and then you can use the product. One more way would be, nowadays on the smart televisions you can use YouTube. So even in that, mostly you have the YouTube application because it's a smart TV, and through that you can use this YouTube product. So clearly you can see the applications in the mobile device or the tabs or the smart TVs or the web browser in the personal computer or laptop. Through these, the end user like me or you are able to use YouTube. For example, currently you are watching my video on YouTube. So you might be using web browser on your personal computer or laptop, or you might be watching this on the YouTube application on your mobile phone, correct? So any platform through which you can use the end product is the client. So the mobile apps or the web browser, they act as the client, because through these the end user, the end customer is able to use YouTube. Okay, so after client, let's move to the next component, which is API gateway. Now I have written here API gateway, but because these are very basic components of system design, API gateway is also representing here the load balancer. Okay, it's a combination, you can say, gateway and load balancer, because we have to focus more on YouTube and not on the very basics of system design. Because if I keep on creating separate components like firewall, gateway, load balancer, then it can take some time and space, correct, in this high level design diagram. So just you can imagine I'm talking about both of the things here, gateway as well as the load balancer. So when we talk about the API gateway, it has three major roles to play. Number one is the authentication of the user using the JWT token. I've discussed about the JWT token and the authentication in these videos. You can refer to these videos to know about it in more detail. Okay, the second major role of API gateway is forwarding the request to the correct microservice. because you can have multiple microservices, and based on whatever URL you are getting, it can forward that request to the corresponding microservice. And the third role of API gateway is rate limiting. Okay, again, both of these components are very commonly used basic system design components, and these are generally used in designing all of the questions. So I'm not discussing about these in detail, but of course, if you want to know in detail about these, you can refer to this video of mine. Okay, now as I said, these two are the basic system design components. Let's focus now more on YouTube, correct? So specific to YouTube, this is our kind of worst component, you can say, which is video upload service, because we are talking about the first functional requirement where user should be able to upload the video. So this microservice, video upload service, will help the user to upload the video. Now, before we talk in detail about the video upload service, there is one more thing that we should talk about. As we know, YouTube is famous for the videos, correct? And the size of video is huge. So the question comes, where do we store the video? Is it database? The answer is no. We don't store the videos in database. Instead of storing the images or videos in the database, we use file storage like Amazon S3. Now, why do we do that? Basically, the file storage like Amazon S3 is cheaper as compared to your database. And because here you have to store video which is huge in size, so saving it in the file storage like Amazon S3 is cost efficient. Apart from that, database provides you good features like CRUD operations and indexing, but when we talk about images and videos, these features are not that useful. Those are more useful when you talk about text. So that's why it's better to store the images or videos in the file storage like Amazon S3 instead of the database. Now when we talk about the video, of course there is that file which is like really big in size, and for that we use the S3. But apart from that, we also have a lot of information or metadata related to video, like what is the name of the video, what is the type of the video, what is the size of the video, who uploaded it, on which date was it uploaded, and much more things, right? So all that metadata, we can store that in the database. So here you can see we have one more component which is our database, and what will happen is like we will store the original video in Amazon S3, which is the file storage, but the metadata of that video will be stored in the database. Now we won't go in detail about the database and the file storage here, but what I've done is like I've created a separate video where I've discussed in complete detail about all of the databases, SQL, NoSQL, file storage, search DBs, and much more, when to use which database. So what you can do is like after watching this video, you can go to that video so that you get more clarity about the databases. Okay, but for now what you can remember is that when we talk about storing images or videos, we generally store that in the file storage like Amazon S3. And when we talk about the metadata related to that video, we store that in the database. So now that we know we will store the images and videos in the object or the file storage like Amazon S3, but who will upload this to S3? Will it be done by the backend? The answer is no. Why? Because say if we have to do it via backend, then first the client would upload that video to the server, correct? And then from the server you will upload it to the S3, which is your file storage. So you can see you are uploading the file twice, and we don't need to do that. And second point is, if you are storing the file in the backend service first, then it needs to have that capability, that kind of storage, right? So if the backend service has to store that much amount of data, because the video files will be huge in size, so it would need that much kind of space. And if the client is first uploading to the backend service, then the roles and responsibility of this microservice will increase a lot. So instead of doing it twice, like first client uploading the video to the backend and then backend doing it to the S3, what we can do is like client can directly upload the video to the S3 storage. Now coming back to the video upload service, let's try to understand the complete flow and the role of this video upload service. So the first step would be that user has clicked on the upload button. So say the video size is 2.3 GB and it has some description, it has title and some more metadata. Now in technical terms, when a user will click on the upload button, what will happen is an API will be triggered. Okay, so as I said earlier, we'll talk about some of the APIs while we are understanding the high level components. Okay, so we'll see some of the APIs here as well. So we have a post API here. If you want to know the basics of API, get, post and other methods, so you can refer to this video of mine. Okay, so coming back, this is a post API, videos, init video. So basically it's a first step. Okay, and of course in the headers it will have the JWT. You can refer to this video to understand more about JWT. And as this is a post request, in the body it will have the information like the file name, the file size, content type, title, description, right? So from the client we are making an API call to the server. Now when backend receives this request, first of all API gateway comes into picture, right? Because we have this JWT token in the headers, so the role of API gateway comes, it will authenticate the user and then it will forward this request to the video upload service, because here the user is trying to upload the video. So now what video upload service will do is it will create a video ID and upload session ID. Why video ID? Because based on this ID we can identify this video. Okay, so it's kind of identifier of the video. So video upload service will create the video ID, and apart from that it will also create upload session ID. Why is that required? Because the size of video is huge, so it can take some time in uploading. So we have to create a session ID through which we can track the progress and we will get the details related to uploading. Now one question may come to your mind is, if we have the video ID, why do we need the upload session ID? The answer is because for a particular video, a user can try to upload it multiple times. Say you tried to upload the video and you cancelled it in between. Next time again you tried to upload that video and it failed due to some network issues. So all such things can happen. You can't keep on changing the video ID for that. So video ID is the unique identifier for that video. The upload session ID is giving detail about that session, like what you tried and what happened. So the progress of upload for that particular session can be tracked by this upload session ID. Now one important question. As we said, the size of the video can be in GBs. If the client is trying to upload the file directly to the file storage, that big file in one API call, there is huge probability that the API call will fail. And just imagine if it fails, that will be a very bad user experience. Say your video was uploaded like 97% and due to some reason it got failed. It can be your network issue, Wi-Fi issue, or bandwidth issue, or any other reason. Now just imagine if you have to re-upload it from 0 to 100%, it is such a bad user experience and there is high probability it will keep on failing again and again. So how do we resolve that? We can handle that by something called as chunking. So instead of uploading the complete file directly, client will upload small chunks to the file storage. Now with this, another question comes to mind. Like when we talk about system design, we don't trust client blindly, but here you can see client is given huge amount of responsibility, and all of this process of chunks and uploading directly to file storage is happening through the client. So should we trust the client blindly? The answer is no. So how do you handle that then? Basically it's the file upload service which will tell the client how many chunks to be created. So here as we saw that the size of video was 2.3 GB. So what video upload service will decide is that it can decide the chunk size we want to keep as 10 MB. So basically the client will upload the chunks and each chunk will be of size 10 MB. So instead of uploading the complete 2.3 GB video in one go, client will upload small chunks of 10 MB size. Okay, and then the video upload service will also calculate the total number of chunks. How? Because we knew the total size of the file. Here we said like 2.3 GB. It was also present in the metadata which was provided by the client in the API body, right? So this was a size in MB only, and we divided by 10. So it will give you around 236 chunks. So instead of uploading one video, the client will upload small 236 chunks. Right? So here you can clearly see we are not trusting the client blindly. The backend service is telling the client the chunk size and total chunks. Now apart from creating the video ID, upload session ID and deciding the chunk size and total chunks, what video upload service will also do is like it will store the metadata in the database. We discussed here, right, that video file will be stored in the file storage, but the metadata of the file will be stored in the database, correct? So that thing will be done by video upload service. So here you can clearly see it is storing the metadata related to that video in the database. It can contain information like the video ID, user ID and the status. So because it is just the starting step, it will make the status as uploading, and then it will also contain some of the metadata related to the upload session, because as I said we will have two things, video ID and the upload session ID. So here is some of the information related to the upload session. The upload session ID will be stored, the video ID will be stored, the total chunks that we have created here, that will be stored, and then it will also have information about the uploaded chunks, because now we have to upload 236 chunks from the client side. It will contain the information of the uploaded chunks as well, because this is the beginning, so there is no uploaded chunks, so we'll mention it as empty, and of course the status is uploading. So we have two tables here and we have stored the metadata like this. Now going back to the question related to trusting the client blindly, right? Even if the video upload service has provided the total number of chunks and the chunk size to the client, still you can clearly see the client has a lot of control here. Client can directly upload things to the file storage service, which is Amazon S3. We don't want to give the direct control to an external user to Amazon S3, because if we allow that, any malicious user can basically upload something here, or some other systems like you can say any other platform or website can directly use our S3. We don't want to do that because S3 is cheaper than database, but still you are paying for that. It's kind of your resource. You can't give the open access to that, correct? So apart from providing the chunks and the size of the chunks to client, you also need to make sure that this file storage is not having the kind of public or open access. So in order to make this process more secure, we have something called as pre-signed URL. This is quite known and popular things. You can say Amazon S3 or any other storage. So basically what happens is like Amazon S3 or other file storages, they provide support of multi-part upload. Like we talked, right? Instead of uploading the complete file in one go, you are uploading small chunks. So it is kind of you are doing multi-part upload. So these file storages allow this kind of feature of multi-part upload, but we don't want to give open access to this file storage. So for that we have pre-signed URL. So currently the client does not have the permission to write or read in the file storage. What video upload service will do is like 236 chunks which it has calculated, it needs to provide pre-signed URL for each of the chunk, and then what will happen is that when client has this pre-signed URL, it gives this client access to upload the file in the particular location of file storage. So basically once the client has the pre-signed URL which has limited expiry for the security reasons, the client can upload the chunk to a particular location of file storage which is Amazon S3. So using the pre-signed URL, we are increasing our security. So basically going back to the roles of video upload service, apart from storing the metadata in database, what it will additionally do is like it will generate the pre-signed URL for each of the chunk. As the number came to be 236 chunks, so it will create 236 pre-signed URLs. So this is for chunk 0, this is for 1, and it will keep on going. So for all the 236 chunks, it will generate the pre-signed URL, and through the pre-signed URL, client will get the access to upload the chunk to a particular location in Amazon S3. So here you can see the video upload service has created first of all video ID and upload session ID, then second it has decided the chunk size, and then based on that it has also calculated total number of chunks. Number 3, it has stored the metadata in the database, and number 4, it has generated the pre-signed URL for each of the chunk. Now this was the request which was made by the client, and corresponding to this request, this response is sent by the video upload service. Status is 200, there is video ID, there is upload session ID, there is chunk size and total chunks. All of this information we calculated here, right? And apart from this, it also provides the pre-signed URLs. For each of the chunk, it provides a pre-signed URL. Now, once the client gets this response from the video upload service, what it will do is like it will split the file into chunks. Although the number of chunks and the size of the chunk has been provided by video upload service only, but the work of creating the small chunks of that size will be done by client. Why? It can't be done by the backend, because if it has to be done by the backend, then backend needs to have the file. So for that, client needs to upload first to the backend, and then backend will do the chunking and then upload to S3. But we said no to that approach because we are uploading twice here, and the backend will need to have the capability of storing that much big storage, right? So instead of doing this way, we said client will directly upload to S3. So the chunking part needs to be done on the client side. Although the number of chunks and the size of the chunk has been decided by the video upload service and not the client. So client has a good amount of responsibility in this system design, but we are not blindly trusting the client. Instructions are provided by the server here. Okay, so basically the step 2 is client will create the chunks. So it will basically split the file into small chunks, and this logic will be on your client side. So if we are using the mobile app, then you can say on the Android app or on the iOS application. If we are talking about the web, then on the front end development, the web development, that logic will be written. Now after splitting the file into chunks, the step 3 would be client will upload the chunks directly to the file storage. As we discussed here, right, the client will directly upload it to the file storage. Instead of going via the backend, the client will do it directly. So the same thing we have mentioned here as the step 3, the client uploads chunks directly to the file storage. Of course, we can do that in parallel. As we have 236 chunks, we don't need to do it one by one. We can do that in parallel. How it does that? Because it already has the pre-signed URL which it has received from the video upload service. So it is a put request, and based on that, the S3 will respond as like status 200, which is like the success case. And additional to that, S3 also returns something called as E tag. Now what is this E tag? So basically E tag is kind of, you can say, the ID or the tag that the file storage is giving you corresponding to the chunk that you have uploaded. So it is kind of a security measure as well, through which the backend will verify that the chunk has been uploaded. So let me show you that flow. So basically we said like client will upload the chunk to the file storage, correct? Now how will the backend get to know this chunk has been uploaded or not? So when the client sends the request to the file storage, in the response from the S3, it will get first of all the status code. Let's assume it was a success case, and with that it will also provide something called as E tag, like we saw in that example, correct? So S3 will provide this E tag to client. So for each of the chunk, then client will send the status of the chunk to the video upload service. For example, if we are talking about the chunk 1, correct? So chunk 1, it uploaded to S3. S3 will say, okay, the upload is successful, and you get this E tag corresponding to this chunk 1. Then client will basically update the video upload service that C1 has been uploaded to S3. With that, it will put some more information that we will see, like the checksum, through which you can basically identify the chunk, just for increasing security, through which the backend can verify whether it's a correct or the same chunk or not. It will also pass the size of the chunk, and it will also pass the E tag that it received from the S3 to the video upload service. Okay, so video upload service now will have the information related to chunk 1, like what is the size and what is the E tag. What video upload service can do is like, instead of trusting the client blindly, it can query S3. So because it already has the pre-signed URL which was generated by video upload service only, correct? And it also knows that we are talking about the chunk 1 of particular video ID. So it can query S3. As I said earlier, Amazon S3 supports multi-part upload. It is a quite common feature which is given by all of the file storage. even if you use some other file storage other than Amazon S3, Google also has a file storage that also provides multi-part upload. So S3 provides features like e-tag and notifications. So here video upload service can query about chunk 1 of that particular video ID, and it also knows like where that chunk is present in the file storage, right? So S3 will return it the e tag, and it can compare the e tag which is returned by S3 with this one which is given by the client, and S3 also provides the status of that chunk, so it can also verify like what client is saying is correct or not. So basically you can see here the backend is not blindly trusting the client. We have given the responsibility to the client so that overall system is optimized, but at the same time we are not blindly trusting the client. Why? The reason is like it's easier to hack or modify the code on the client side as compared to the backend side. We are getting the information from client because that is part of our system, but we are also verifying things. So the same thing that I explained it to you here, let's try to see in the flow. Okay, so we said that the client will split the file into chunks and client will upload the chunks to the S3, and based on that S3 will give it the status code and it will provide the e tag, correct? So the next step is after each of the successful chunk upload, what client will do is like it will inform the backend like I told you in the image, correct? So it will make another API call to the backend. It is same as this thing. When it gets the e tag and as it knows it was a success thing, it will update the backend. So how will it do that? Using the API, correct? Inside that API it will pass the information like what is the chunk ID, what was the video ID that we are talking about, what is the e tag that has been received from the file storage, what is the chunk size, all that kind of information it passes to the backend. So clearly here you can see this is the post API. It is passing the video ID, correct? And it is saying like upload session for this particular session chunk complete. So basically it is updating the backend service that for this chunk of this video ID of this particular session, this is the status. So chunk number was this 5, this was a chunk size like around 10 MB, and this is the checksum. Okay, so here the checksum is the e tag only. Okay, so it can directly pass the e tag or it can say it as the checksum through which you are basically verifying that this is the chunk. Okay, so ABC123, as you can see, this was returned to the client via file storage. This was the e tag, and the same e tag we are passing as checksum, or you can directly say it as the e tag that it is passing to the backend. Now once the backend receives this API request from the client, what it will do is like it will call the Amazon S3 or the file storage, because as I said it will verify the things which are mentioned by the client. Okay, so as it knows it is about the chunk 5, correct? And we also know the video ID, right? We also know the upload session ID, correct? So based on that it will basically call the file storage and it will verify whether this object exists, whether the size matches or not, whether the e tag matches or not. We got the e tag here. The backend will also get the e tag from the file storage because it is calling the file storage, and through that it will get the status of that chunk and it will receive the e tag. So it will verify whether the e tag that it received from the S3 storage matches the one which has been sent by the client or not. So in case the verification is successful, it will update the metadata in the database. So if you remember, in the database we had this information of uploaded chunks, correct? Because you have like 236 chunks now. The database containing the metadata is having the information about the uploaded chunks. In the beginning it was set to empty because it was a start of upload, but now what it will do is like it will modify it, it will update it to uploaded chunks dot add 5. That means like chunk number 5 has been uploaded. Now after this, the next step is this process is repeated for all of the chunks. Like we discussed, what client will do, it will upload it to S3, it will get the response from S3, then it will update the video upload service, and then what backend will do, this process will repeat for all of the chunks. And talking about the failure case, if the network breaks in between, what client will do is like it will call the API, and through that it will try to fetch the upload status from the video upload service. Okay, now because the database is containing information related to the uploaded chunks, correct, which we modified here as well, correct, we keep on adding all the uploaded chunks, right? So what backend will do is like it will provide like what all chunks have been uploaded, like for example 0 1 2 3 4 5 6 7, so till whatever number it is, it will provide like all of these chunks have been uploaded. So what client can simply do is like it can simply check what all chunks are missing, and it will resume uploading only the missing chunks. So in this way, even if you get a network issue like Wi-Fi was not working, then next time you don't have to upload the video from the beginning. You can simply upload the chunks which are missing. So once the client has uploaded all of the chunks, what client will do is like it will tell the backend that I have completed the upload. So it will call an API, something like this, which is a post API. It contains the video ID, the upload session ID, and it says complete. So now the backend can verify this. First way, of course, is like as we said, for each of the chunk, the backend can check with the Amazon S3. It can verify the things are matching or not. There is one more way which has been provided by the file storage Amazon S3, which is something called as the notification. So this feature is like when we are doing multi-part upload, the backend can subscribe to the notification of the file storage Amazon S3. Once the multi-part upload is complete, the S3 storage can notify the backend service that the upload has been completed. Okay, so there are multiple features which are provided by this file storage like Amazon S3. It provides support of e-tag. It also provides that notification support. So based on that, the backend can basically verify that the upload has been completed. Okay, and once the backend has verified that everything is okay, it will update the upload session status as completed, and similarly the video status is processing. Why processing? Because there are many other steps which are pending that we need to discuss. We have just uploaded the video, but there are many more things which are part of YouTube. Okay, so after this, the next step is this video upload service will publish an event to Kafka. Now you will say, what? Why to use Kafka here? Don't worry about it, we'll discuss. But for now, let's continue. It will basically publish an event video uploaded to Kafka, and it will also provide the video ID with it. And alongside that, it will send the response to the client that video upload is successful and video is processing. Why does it say video is processing? Because there are a lot of things that are part of YouTube. For example, there are different resolutions. Like you can see video in 144p resolution or 360p resolution or 720 or 1440 or even 4K. So all that kind of things needs to be done after the basic video upload is successful. Okay, but the main point is the work of video upload service is done here. Okay, so let me go back to the diagram so that I can explain you again in the summary, because it can become a bit complicated. Okay, so first there is client, which would be your mobile app or your browser through which the end user is using YouTube. Then there is API gateway, which will do the authentication of user, forward the request to the correct microservice, and rate limiting. Okay, so client sends a request that client wants to upload a video, correct? So it goes to the video upload service. Now we have some metadata related to the video that is stored in the database, correct? And the actual video will be stored in file storage. But who will store that video? Not the backend, it's the client. But we don't want to give the complete control to client. So what video upload service will do is like, as it knows the size of the video because it was provided by the client, it will decide the chunk size, say 10 MB, and based on that it will say total number of chunks that will be there for the video. Okay, now client will upload the chunks to the file storage instead of the complete video, but client does not have the access to upload on the file storage. For that, the backend will provide the pre-signed URL for each of the chunk to the client. Now client has the pre-signed URL through which it gets the access to upload things on the file storage. So for each of the chunk, it will upload, and that can happen in parallel. Whenever the client sends a request to upload a chunk, if it is successful at the S3 storage, in the response, the client will get the success, and with that, it will get the E tag. So E tag is a mechanism through which you can verify the things about the chunk that you have uploaded, because S3 storage supports multi-part upload. Okay, so whenever the client gets the E tag for a chunk, it sends it to the video upload service. It sends information like what was the video ID, what is the upload session, what is the chunk ID, and the E tag. Now because the video upload service does not want to trust the client blindly, it will verify that. So it will check with S3 for that chunk. It will get the status from S3 and it will also get the E tag. So it will match this E tag with the one which has been provided by the client. And based on that, video upload service will verify whether everything sent by client is correct or not. So once client has uploaded all of the chunks, it will update the backend service, and backend service can also subscribe to the notifications of the S3 file storage, which is the feature provided by the file storage. And once the upload is completed, it will notify this backend. And also from the E tags, it can verify that all the chunks have completed. So based on that, it will update the metadata, and it will also update the client in the response that the basic video upload is done or complete and rest of the things are in progress. And what are these rest of the things? It would be like you have to provide different resolutions to that video, because if the client has poor network, say the client was watching the video in 4K but then there was a poor network, then the client needs to switch to the lower resolution like 720p so that client can see the video, because in 4K it will take a lot of time as the bandwidth is low. So instead of watching in 4K, client can watch in the lower resolution, and that can happen automatically as well, because there is a feature which says like auto update the resolution based on the bandwidth, right? Apart from that, also we need to generate the thumbnail, we need to check the copyright issues, also we need to manage the recommendations, the search, all of such things that are part of the YouTube. So this was just for the video upload service, and in order to handle all of the other functionalities, we will use Kafka. So the video upload service will publish an event to the Kafka through which other microservices will consume that event and perform their task. So till now, this was a flow of uploading the video. Now one question when we talk about the pre-signed URL, is it generated by the video upload service or the S3? The answer is it is generated by the backend, that is the video upload service. It is not done by S3. So how does that happen? Basically backend has the AWS credential or the role through which it can access the S3 storage. So the backend will call the AWS SDK or whatever SDK provided by the file storage which you are using. Then the SDK locally computes a pre-signed URL using the access key, secret key, and the request details. So based on that, your backend service will generate the pre-signed URL for all of the chunks. One more thing to remember here is, as we had like multiple chunks, like we had like 236 chunks, so the backend will generate one pre-signed URL per chunk. So it will generate 236 pre-signed URLs. One more question that may come into your mind related to this is, we said like backend will verify the E tag with the S3 storage, right? So it gets the E tag from client, it will also get it from the S3 storage and verify it. Do we need to do it at that time when we get from the client? We can do any of the ways depending on how you want your system to work. You can do it when you get it from the client side. You can simply make a call to the S3 and based on that you can verify. Another way could be that you can do it in batch. So if you want to check the status of the chunks, you can also send multiple chunks to the S3 in one go. So you can also do in the batch processing depending on the load and how much you want to verify. So you can also use the hybrid approach. When you get it from the client side, you can do it at that time, and you can also check at the end when the upload is complete. So you can pass all of the chunks together and check the status. Okay, as we mentioned that after doing all of these things, the video upload service will publish an event video uploaded to Kafka. So let's create another component here, which is Kafka, which is the message queue. Now what is the role of Kafka? Basically it's a durable distributed event log. So there will be a producer, like for example the video upload service has produced an event like video uploaded, and corresponding to that event there will be multiple consumers. And the good part is these consumers can consume the event at their own speed asynchronously. Now a basic question comes to our mind: why YouTube needs Kafka? The answer to that question is, till now we have just uploaded the raw video, but once the raw video is uploaded, there are many other things that needs to be done for the YouTube system design. We need to do transcoding of videos. Why? Because in YouTube you are given an option to select the resolution. For example, you can select it to auto or 144p, 244p, 1080p, or even 4K, correct? So there are different resolutions present, and that is done at this step of transcoding. This is really useful because sometimes the network quality can be low, so a user won't be able to always see a video on 4K. Depending on the network or the bandwidth, the resolution should also adjust. So we need to make sure that we have all the videos in different resolutions. Another thing that YouTube does is it generates the thumbnails, and it provides an kind of option to the user like which thumbnail you want to set. Apart from this, YouTube also does like copyright scanning if there are any copyright related issues in your video. Then another thing that it does is search indexing, because in YouTube you are given an option to search, correct? So corresponding to each of the video it needs to do the search indexing. And there are many other things like the feed updates, notification, analytic events, and much more. So you cannot do all of these things synchronously. So instead of that, what we will do is like our video upload service will publish an event video uploaded to Kafka, and there will be multiple consumers that will consume this event from Kafka, and they can perform their task asynchronously. Now when talking about the transcoding, thumbnail generation, copyright check, that can be handled by the video processing service. Now in video processing service, we will have multiple different components involved because we have to do multiple things here. We need to do the transcoding, we need to generate the thumbnail, we need to check for the copyright, and much more. Similarly, we will also have one more service which will be the like and comment service, because as you know, on a video user can also like or make the comments. So we need to have a service that handles that. Now apart from these two, we may have a few more services, like we have the recommendation service, because on YouTube generally you get the recommendations, correct? And this service will handle that. Additionally, we will also have a search service, because on YouTube user can also search for the videos, right? So this service will handle that operation. Of course, we have other things as well, like the analytics service and much more, but those are out of scope for our video. So mainly you can see we would have like video processing service, like comment service, search service, recommendation service, analytics service. So you can clearly see even after uploading the raw video, there are much more things that we need to do. There are many other services present here. So instead of video upload service talking directly to each of these service, the communication between these services will happen through the message queue, which is Kafka here. Now a very basic question comes to our mind, which is why not just call services directly? Here we saw that video upload service is talking to other microservices using the Kafka. Why not do that directly? The answer of that is, if the video upload service is talking to all of the microservices directly, then we would end up in the synchronous calls. And if we do the synchronous calls, then overall the video upload flow will become very slow. There will be high chances of failures, and there will be tight coupling. Also, that increases a lot of responsibility of the video upload service, and the direct communication between service is not a good idea for high scalability. Now by using Kafka, we get asynchronous processing. So basically when we use Kafka, multiple consumers can consume this message at their own pace, and that too asynchronously. Okay, Kafka also provides loose coupling. So here when we were doing the communication directly, we had tight coupling, and by using Kafka we will have loose coupling. Another great feature of Kafka is that it provides durability. How? So basically the retention period of Kafka is generally 7 to 30 days. So you can just imagine, like, for weeks an event will be stored in Kafka. So even if there is a failure, like this video processing service was trying to consume an event and it failed, what it can do is like it can retry, because the event will stay in Kafka for 7 to 30 days. So it provides you durability, and hence the consumers can retry in case of any failure. Now, apart from that, also there are many other features which is provided by Kafka. Hence, instead of video upload service talking directly to other microservices, we will use Kafka in between. So any of the microservice can publish the event to Kafka, and multiple other microservices can consume that event. For example, here the video upload service will publish an event video uploaded to Kafka, and then other microservices will consume that event. Now let's see what role Kafka plays here. Okay, so what will happen is, after the video is uploaded by the video upload service, it will publish an event to Kafka, and the event name would be video uploaded, because video upload service has uploaded the raw video, correct? And with that, it will also provide the video ID. You remember the video ID? It was generated by video upload service. Video upload service generated the video ID as well as the upload session ID. So it passes that same video ID to the Kafka event. So video upload service is the publisher here. Now there will be multiple consumer to this event. First of all, the transcoding service, which is part of this video processing service, okay, that will consume this event, and it will generate different resolutions of the video. Just like we saw here, you get this options, correct? Like what resolution you want to play your video in. So that is generated by this part, transcoding, which is part of the video processing service. Then the video processing service also has one more component, which is the thumbnail related worker, which will consume this event and it will generate the thumbnails. Similarly, one more consumer will check for the copyrights in the video. Now the role of Kafka is not just limited to this video uploaded event only. Okay, here we have seen, like, after video uploaded event, all these actions will be performed, but even after that, Kafka's role will come into picture. Like, for example, once we are done with the transcoding, and we know that transcoding will be part of this video processing service. So once the transcoding is done, what video processing service will do is, like, it will publish an event which will be video processed to Kafka. Okay, and then again there will be multiple consumers of that event from Kafka. Let's see about that. Okay, so here you can see, once the transcoding is done, the video processing service will publish an event which is video processed, and with that it will also pass the video ID, correct? So after that, there will be multiple consumers. CDN will be one consumer. I haven't created the CDN component in this diagram yet, so for now ignore that. We will discuss about CDN later in this video. Okay, but apart from CDN, search indexing service will consume this event. Recommendation system will also consume this event, and notification system will also consume this event. So clearly you can see, any of the microservice can publish event to Kafka, and multiple other microservices can consume that event and perform their task asynchronously. So let me put these events in the diagram here. So first, let me put here that the video upload service generates the video ID and also the upload session ID, right? So these were generated by this video upload service. And then when the raw video has been uploaded, what video upload service does is it publishes an video uploaded event to Kafka. So we have mentioned this event video uploaded, which is published by video upload service to Kafka. Now this video uploaded event which has been published in Kafka will be consumed by video processing service. And once the video processing service has completed the transcoding, what it will do is, like, it will publish an event to Kafka, and that event would be video processed, correct? And this event video processed will be consumed by many other microservices or components, like the recommendation service will consume it, the search service will consume it, and much more. Now because here we are talking about Kafka, let's discuss one more point here. not just video uploaded or video processed. Kafka will handle many more events. For example, the like comment service will also upload the events to Kafka, which will be used in many places, and it will be also used for analytics. Let's see about that. So basically, the like comment service and other microservice will add or publish the events in Kafka like video viewed, video liked, comment added. So clearly you can see if a video is viewed, that event is published to Kafka. If a video is liked, then that event is also published to Kafka. If a comment is added to a video, that is also added to Kafka. We'll discuss more about this when we discuss in detail about the like and comment service. But for now, you can clearly see these type of events will also be put in Kafka, and there will be multiple consumers for that, and based on that we will generate real-time counters like what is the like count, comment count. It will do the recommendation training, because based on how many times a video has been viewed or liked or shared, based on that the recommendation will also change. We will also have a mechanism to check for fraud detection, because a lot of times people just play the video using the bots, correct? So YouTube generally detects that. So that will happen by a separate component, but this event video viewed will be consumed by that component, and then it will check for fraud detection. Similarly, the concept like trending calculation, there will be a component which checks for whether a video is trending or not. But you can clearly see this component, whichever component is this which is performing this task, will consume this event from Kafka. And in similar way, there will be a component whose role will be to create analytics dashboard, and that will also consume the event from Kafka. So clearly you can see Kafka is playing a very major role here. A lot of events will be published to Kafka, and multiple consumers will be there which will be consuming those events and then performing the action. So let me add these events as well in this diagram, because we are discussing currently about the role of Kafka. So here I have added few of the events that will be published to Kafka, correct? Of course, there will be many more events, but these are kind of the sample events which will be published by these microservices. Now, apart from this, let me create one more component here, which will be the notification service. Although we will not discuss in detail about the notification service in this video, because we are focused on 2-3 major functional requirements here. But yeah, this would also be part of the YouTube system design. So clearly you can see Kafka plays a major role in this system design. Kafka is built in such a way that it can handle a lot of load. Okay, one doubt may come into your mind is like, why are we using Kafka here and why not database? So the reason is like, if we write all of these events in the database, it would be quite slow, it would be quite expensive as well. And another point is, if we use database, it will be hard to fan out to many consumers. Clearly you can see for each of the event that we publish, there are multiple consumers. So using database, this thing becomes like difficult. And when we talk about Kafka follows append only log, and it is built in such a way that it is great to handle huge amount of scale for these kind of events. Kafka performs sequential disk writes. It is not same as the write operation in database. If you make so many write operations in DB, it will be difficult to handle, whereas in Kafka, it is built in such a way that it can handle that part. Kafka is different from database, because in database, when we talk about persistence, we talk in long term, right? For many years, data will be persisted, correct? But when we talk about Kafka, the durability is there, but the retention period is like for few weeks only. Like I said, like 7 to 30 days. It is not like database where data will remain there for like many years. It is just for few days, so that even if you have some failures, we can do the retry. So it provides some kind of durability in that terms. But data we use here are the events which we don't want to persist for very long term. Okay, another important thing about Kafka is like, for these events it is extremely fast. So it's already a distributed system, so we don't have to worry about like how it will handle that load, or how it will handle the distribution and scale. So it can handle millions of messages per second. So that's why Here we are using Kafka for the communication between multiple microservices and the components. Okay, so we are not going to talk in very much detail about Kafka in this video because we are focused on the system design of YouTube here. But of course, if you want me to discuss about Kafka in detail, put that in the comment section and I'll create a separate video on Kafka. Now next, let's discuss about the video processing service. So first of all, this video processing service comes into picture when video uploaded event is published to Kafka. This is listening to this event, or you can say video processing microservice consumes this video uploaded event. So let me create this arrow here which shows like the video processing service is consuming this video uploaded event. Now this video processing service performs a lot of things. So let me create a separate component here where we will see what all things are done inside the video processing service. So this is our video processing service. Now first of all, it contains a module which takes care about the transcoding. So what this will do is like first fetch the raw video from S3 because the video has been uploaded to S3, correct? Now we want to create separate resolutions of that raw video. So you had a video, now you want to create all the different resolutions like we saw on the YouTube, 144p, then you have 360p, then apart from that you have few more resolutions, right, like 240p, 480p, 720p, 1080p or 4K as well. So all of these resolution will be created by this transcoding component. So in order to create all this resolution, first it needs to fetch the raw video from S3. Now because we have multiple resolutions present here, what transcoding component has is the multiple workers present inside it. Okay, so there will be multiple workers and each of the worker will be assigned one of the resolution. So here it would have multiple workers present. Okay, and each resolution will be assigned to one of the worker. So for example, this worker is handling 144p, this worker will handle 360p. So like this, one resolution will be assigned to one particular worker because you can clearly see there are many resolutions and we cannot handle all of these to one worker because every resolution will take some time. When I say worker, you can assume it as like CPU optimized machines, and these are auto scaled. For example, there is huge amount of load, so based on that each of the machine will handle one resolution because at a time you can have multiple videos that are getting uploaded by different users, and for each of the video you have to create different resolutions, correct? So you need many workers there. So here workers represent CPU optimized machines and those are auto scaled because you would require thousands of workers. So clearly you can imagine each of the resolution is a separate job. This is a separate job which is handled by this worker. This is a separate job handled by this worker. So to summarize, the transcoding component first fetches the raw video from the Amazon S3 file storage because we stored the raw video in the Amazon S3 file storage and that was done by the client. If you remember from here, client directly uploaded the video in chunks in the file storage. Now because video processing service needs to create all the different resolutions, so first it needs the video. So its component transcoder first fetches the video from the Amazon S3 file storage and then it generates the different resolutions. How? Using the workers. Like we see here, there will be multiple workers and these are auto scaled and each of the resolution is handled by a different job. Now another component which would be part of this video processing service will be segmenter. Now what's the role of segmenter? Basically when you watch the video on YouTube, it's not like the complete video comes in one go. Basically just imagine this video was like 3 hours 45 minutes, correct? So if on the client you want to stream this video or watch this video, then if you fetch the complete file in one go, it will take a lot of time, right? Because it's huge in size. So instead of giving you the complete file in one go, which will take a lot of time, what we do is like we fetch small segments of the video. So for that we have this segmenter component which will basically create small segments of the video so that the end user can fetch those small components very quickly. Like in 1-2 seconds you get that one segment, then you can fetch the next segment because you will start from zero, correct? And then you will slowly move to the next segments. So what our system is like, it will first consume the starting segment and then in parallel it will fetch more segments so that there is least amount of buffering when a user is watching the video. Okay, and that thing is performed by the segmenter. So this component of transcoder, basically it will generate different resolutions, and for each of the resolution we need to create small segments of the video. Now when I say we have to create small segments, it may create a doubt in your mind, which is like when we talked about uploading process, we said we don't want to go through backend because it is like first we are uploading from client to backend and then from backend to the S3. So we directly uploaded from client to S3, correct? And here we created small chunks, right? Because you cannot upload the complete video in one go. So you created small chunks and each of the chunk was uploaded to S3. Now here in video processing service also, you are basically creating small segments. So you might think like, what are we doing here? We are doing the same things again and again. But actually the thing is here we are focusing on like how user will view this, like when end user is watching the video, right? And the important part to understand here is when we are talking about the upload flow, it is just one user who is uploading the video. So the chunks that we created here can be slightly bigger in size, right? We said like 10 MB can be one chunk size, correct? Because this one user is uploading the video and the user is aware that uploading takes some time. But when we are talking about end user watching the video, we want least amount of latency, because if there is buffering, no one is going to watch, no one is using your product, correct? So we want least amount of latency when an end user is watching the video. That was part of our non-functional requirement, right? So here when we are creating these segments, these might be different in size when we compare it with the uploading chunks. Okay, these segments might be even more smaller, so that when user opens a video, directly at that time you can download that small segment so that user can see that starting segment, and meanwhile you will fetch more segments, correct? And you can show those segments to the user so that there is least amount of buffering. You might have seen when you open a YouTube video, generally it shows like it is loading. It doesn't load the complete video in one go. So the point is we don't load the complete video in one go, we load the small segments, correct? So the segments that we generate here may be different from the chunks that we generated here. Okay, and for uploading we created that process to reduce the complexity at that time. Here we don't have any other choice, like we have to create the different resolutions, we have to create small segments, so that needs to be done by server only. So basically once we have created the different resolutions and we have created small segments, it also creates one of the file which is called as the manifest file. So let me write here manifest file. Okay, so in this manifest file we will have details like what all resolution of the video are present, and also information related to the different segments of that video. Okay, so that information will be present in this manifest file, and later we will see like the client will use this manifest file, and based on this the client can show you the information related to the quality, like which all resolutions are present. So that information would be present in the manifest file. Next, apart from these components, there will be one more component which will be the thumbnail generator. Okay, so if you have ever uploaded a video to YouTube, you might have seen that YouTube generates some of the thumbnails automatically, and it gives you an option like if you have not uploaded a particular thumbnail, you can use the thumbnail created or generated by the YouTube. And how it does that, it basically checks some of the frames of the video, because now we already have the video here. First we fetched the raw video from the S3, and then we created different resolutions of that video. So we already have the video. So what thumbnail generator will do is like it will fetch some of the frames from that video. It will see some of the factors where the quality of the frame is good. Like for example, if you are in the video, your face is not blurred, all such basic logics it will apply, and based on that it will recommend you 2 or 3 thumbnails which are automatically generated from the video. Another component which will be part of the video processing service is content moderation and copyright. So basically this component will check if there is any copyright related issue to the uploaded video. So it will check the audio, like for example if you use audio like a movie song that you're using in the video, it will simply detect that. Some of the video components, it can also detect that. It will also apply some of the policy checks, and it can also use machine learning in detecting any of the copyright content. So in case it detects the copyright related issue, it flags that, or it can also block the video. Now here one more thing about the thumbnail generator. Basically, as I said, it will go through the video, some of the frames, and it will try to detect some of the best frames where for example the face is not blurry, and then it will generate 2 to 3 best thumbnails. Okay, and one more thing about storage here is like the video is stored in S3. Similar to that, the images are also stored in S3, because images and videos both are considered as the blob object, and those are stored in the S3 instead of the database. Okay, and similarly, as the raw video was stored in S3, the different resolutions that we created using the transcoding component like 144p, 360p, so we will have multiple videos created now, right? So all of these will also be stored in S3, because videos and images will always be stored in the file storage. So we are using Amazon S3 here. So the thumbnails and all the resolutions, all of these will be stored in S3. Now in Amazon S3, we will store it something like this. First, you can see about the raw video, okay, the one which was uploaded by the client, right? So it contains a video ID, upload session ID, and all the chunks, because from client we uploaded small chunks of the video. We don't upload the complete video in one go, right? The client creates small chunks, although the video upload service told about the number of chunks and the chunk size, but it is the client who will basically divide the video in small chunks and then upload those chunks to the Amazon S3. So this is how it will look like. First is a raw, because it is the raw video which has been uploaded by the client, then the video ID, upload session ID, and what chunk is it, because there will be multiple chunks associated with the video, right? And when we talk about different resolutions, those will be considered as processed versions, because we are creating different resolutions from the raw version. Okay, so these are processed ones, and again we have the video ID, then the resolution like 240p, 144p, 360p, 720p, 4K, whatever it is. And then we have this segment, right? This segmenter created small segments, correct? So we are not uploading the complete video in one go, we have small segments. So segment 001, right? So this is a way you can see in S3 we have all of the videos and images present, correct? So we check for 240p, we similarly we have for 720p, and as I said, thumbnails will also be stored in Amazon S3 as these are images, correct? So it will have something like thumbnails, what the video ID was, because thumbnails are associated to a video, correct? So we have the video ID and then the name of the thumbnail. Okay, so in this way we will have the images and videos present in the Amazon S3 file storage. Next, let me tell you in brief about the copyright version, because it might be a bit confusing, like how does that happen. So let's see, as I told you, like it will check for the copyright on both the audio as well as the video. So first, if we talk about the audio, what it will do is like it will convert the audio to frequency signature, because the audio is like, of course, the frequencies, different frequencies, so it will convert that into the frequency signature, and then it will create the hash sequence of that. Okay, and then once it has created the hash sequence, it will compare with the copyright fingerprint DB. So it already has a database where it has the fingerprints of different audios, so it will compare that hash with those, and just in case there is a match found or there is a partial match or similarity, it can detect the copyright there. Now after audio, if we talk about the video, in video it will extract the keyframes and it will compute the hashes for that, and again it will compare those with the known copyrighted frames. Okay, now we will not go in much detail of this. I just wanted to give you a brief about it because it will involve like machine learning and few complex algorithms, and this is not in scope of our designing part. Okay, so we just need to tell like this will be one of the component, but of course the interviewer won't go in detail about tell about the copyright, because we can simply say this is one of the components and we can focus on the complete YouTube features that we are trying to design here. Okay, but the main part here is that this process of checking the copyright will happen in parallel to like the transcoding phase. So all of these things basically, these are happening in the background asynchronously, and at that time user will see something like processing. Okay, your basic raw video has been uploaded, but there are some processing steps that are happening, so user will see processing, and in the background all these things will keep on happening. Now if we talk about that transcoding part, like who will decide what all resolutions will be present, so that will be decided by backend only. There can be multiple factors on which you can decide this, like for example what is the resolution of the raw video. Correct, we saw here the raw video which was uploaded by the end user, right? So if the raw video is like 1080p, correct, so then you won't create a higher resolution for it. You can't create 4K for it. If it is 4K, of course you can create like lower versions for it in case a person has uploaded the video to 4K, correct, but the end user who is watching the video might not be able to see that in 4K because of the restricted bandwidth or the network. Correct, so you are providing like lower resolution options as well, so that in case in beginning the user was watching in 4K but suddenly the network dropped. Okay, like the Wi-Fi stopped working and the user's mobile switched to the mobile data which was not that fast, or you were like traveling and instead of 5G network now you got like 3G or 2G, right, which is quite slow. You can't get that 4K frames quickly in that. So in that case your client can directly switch to the lower resolutions like 360p 144p, so that at least user can watch the video, right? So first it depends like what is the resolution of the raw video which has been uploaded by the client. Then there can be other factors like the cost policies, what is the popularity of the creator who uploaded the video, and many other things. But basically you can imagine the biggest factor would be the resolution of the raw video, you can say. Like as we said, we would have multiple workers here, and workers represent the CPU or GPU optimized machines, and those will be auto scaled. So you will have many workers out there, and each of the resolution will be assigned a separate job, like an individual worker handling only one particular resolution. Here it's not like one big worker is handling all of these things because the transcoding will take time. Okay, so there will be one worker assigned to a specific job related to a specific resolution, you can say. But just in case you have huge amount of load, like a lot of people are uploading the video, and although I said like the workers will be auto scaled, but just in case we imagine like the number of uploads were higher, because for each of the upload you have to create so many resolutions, correct? So just imagining a case if the workers are limited, so what we can have is a queue. Okay, and we can input the video in the queue, and of course the workers will keep on picking from the queue. Correct, it's kind of similar to producer consumer problem that we generally have. Like you might have seen one example where we have a queue and there are few threads, right, and thread keeps on picking the task from the queue. In similar way we can think in this terminology, just in case the workers are limited and we have huge amount of uploads, so we can maintain a queue and the workers can keep on fetching from the queue. And because this is happening in the background and user is already aware that the raw video has been uploaded and there are some processing which is happening on the YouTube side, it generally says converting to 4K or converting to 1080 or higher resolutions. It provides that kind of information, so user is fine with that because user knows, okay, my upload is successful, it's safe now, YouTube is performing its own task, and I can ignore it for now. Like I can come after some time and simply open that and see that in the unlisted kind of section you are safe from your side because you have uploaded your video. So this is kind of asynchronous things which are happening in the background. Okay, so this is fine in that way. But overall you can imagine something like this. First of all, we will download the raw file from S3. That happens using the transcoder. Why do we do that? Because we have to create different resolutions for that raw file. So we need to get that video from the S3 file storage. We haven't stored that in the database because videos and images are stored in like file storage, like we are using Amazon S3. So we need to fetch that file from S3, and then we will run some of the things like the FFmpeg or internal encoder, which will decode it first. It will resize, like whatever size we have decided, it will resize, and then again it will re-encode it. Okay, so this all was done by the transcoder component inside the video processing service. Now that we have generated different resolutions, next we need to split those into small segments, because as I said, when the user is watching the video, we don't get the complete video in one go. Why? Because the file is huge, it's quite heavy. If you try to get the complete file in one go, there will be huge amount of buffering, which we don't want. So what we do is like we create small segments using this segmenter component, right? These small segments might be different in size to what we discussed in the chunks while uploading, because uploading is a different flow and viewing is a different flow. We want least amount of latency while viewing. Okay, so these segments will be very small in size so that when user opens the video, you directly get that first segment very quickly, so that there is least or no buffering. Okay, so with these parallelly, we also have like thumbnail generation and copyrights check. And once we do all of these, and then basically we will upload the output to S3 again. So all of these resolutions which we have created and the thumbnails, those will be uploaded to the S3, and based on that we will say success or failure of the processing part. And as we said, like we will upload it to S3. On S3 it would look something like this. Okay, so in the videos we have the video ID, because everything is related to that particular video and we associate it with the video ID. So inside that you will have the raw video which was uploaded by the client, then you will have different resolutions out there, and you will have the manifest file, the one which I mentioned here, which will have the information about all of these resolutions, because we will also send this manifest file to the client so that the client can show different resolutions available, like we saw here. Correct? So this information comes from the manifest file to the client. Okay, so this is how it will appear in the Amazon S3. So here in this step of creating the resolutions, we can think of some optimizations in terms of cost as well. Like you have to create different resolutions and then store them. So what we can do in terms of cost optimization, in case it's required, it can be immediately we can generate like 360p, and the higher resolutions we can create based on the popularity of the video. Or what we can do is like the resolutions which are kind of rarely used for the video, we can put that in the cheaper storage. Or what we can also do is like delete some of the resolutions which are never used. Okay, some of the optimization related to cost we can make. If asked, you can tell or recommend such kind of things. Okay, now a question may come into your mind, like in the transcoding phase we said like we will download the raw file from S3, correct? So the server is downloading the file, which can be huge in size, and then we are also creating some of the resolutions here. But in the start of the video we said that we would upload directly from client to S3 because we don't want to store the large files on the server, because server would need that much capability to keep all that storage. Correct? So in order to avoid that storage on server side, we uploaded directly from client to the S3. Okay, but now we are saying the video processing service will download the large file from the S3. So the same question comes again, like how do we have this capability of storing this much huge amount of files on the server now? Because we said earlier we don't have that capability. So the answer to that question is yes, we download the file from S3, but this is a temporary storage. Okay, we don't store the file for long. It is just stored on disk for temporary basis because we have to generate the different resolutions here, and we have to do the segmentation of that. And once we have uploaded it back to S3, we will remove or delete those files from the server. So server is not basically keeping or storing those videos on server or database. Okay, we are simply downloading those on temporary basis just to create different resolutions, segment those, and then again give it back or upload it to the S3, because S3 cannot do all that thing. This needs to be done by your backend, your servers. Okay. Here, if you do this on the temporary basis, you can do that. First from client, you upload it to the server, and then from server to S3. But it's kind of like, as this is temporary, you are going to delete it, correct? So it is not serving you in any way. You will do upload twice. So it will take even more time. First from here to here, then here to here. Okay. And then you will delete the video. What's the point here then? You simply upload directly here to here. Okay. But when we talk about this step, you don't have any alternative. Backend has to create all the different resolutions and then the segments, correct? So it needs to download that, but we are not saving that file for long time or in the database. We are simply doing it on the temporary basis. Once your work is done, you upload it back to the S3 and you delete that file. Okay, so it is something like this. The S3 has the permanent storage of the videos and the images. Then from the S3 we will download it in this transcoder phase, where the workers will have that temporarily on the disk or pipeline. And then once its work is done, once we have created different resolutions according to our requirement, once we have done the segmentation, we upload it back on the S3. Okay, and then the temporary file will be deleted. So in terms of permanent storage, S3 will contain the raw file as well as the different resolutions which has been created by the transcoder in the video processing service. And we won't have that file in long run inside the backend or the database or the service. That will be only stored permanently in the S3. Now going back to the components in the video processing service, we discussed mostly about all of these in like brief. I know you might still have some confusion related to transcoding one. So let me give you some idea on that part, but we won't go in like huge detail on that side. I'll just give you some brief on that part. So as we mentioned, in the transcoder we will have many workers, and one of the resolution will be handled by one job which will be handled by one worker. So it's not like one big worker is handling all of the resolutions. It is one worker handling one of the resolution. So inside the worker, the first step is the decoder. So it will decode the file and then it will read the HD frames, because what we are trying to do is we have the raw file and we are trying to generate the lower resolutions, correct? So it will read the HD frames and then it will do the scaling, because we are creating the lower resolutions. So it will simply downsample the frame to the lower version, whatever we want to do. And then after doing the downsampling, as we decoded the file, we need to encode it again. So it can do something like this. It compresses using the H264 or other algorithms, you can say. And basically this flow can happen using tools like FFmpeg, and then you can apply these kind of commands. Okay, so it automatically does that. And when we talk about this step of downsampling, you can use some of the algorithms or you can also use machine learning here, but we won't discuss about that in detail here. But yeah, this is the overall flow, you can say, which happens for transcoding. It will decode the file, it will read the HD frames, and it will downsample those, and again it will encode the file. So with this, say you had the resolution present as 1080 loaded by the client. So using this, you can create the like lower resolutions like 360p, 720p, 144p, correct? So basically this step will be performed for each of the resolution, because you have to provide the downsampling resolution, correct? So that's why we have different workers performing that. But yeah, they can do the work in parallel. So each of this will work on a separate worker. Of course, we can see this step is bit expensive and time consuming, and that's why we talked about some of the optimizations that we can make here, like converting it to 4K resolution that you can delay, or do only if the video is becoming popular. You can also delete some of the resolutions which are not getting used, or put some of the resolutions which are rarely used to the cheaper storage. Okay, so we talked about different resolutions that will be created by this transcoding component inside the video processing service. Now one doubt that may come into your mind is like, how about the aspect ratio? Like in mobile device you have to show differently, whereas when you are using the laptop the screen is more wider, correct? So how do we manage the aspect ratio? Is that also handled by the video processing service? The answer is no. But before understanding that, let's try to get the basic idea of aspect ratio. So basically the aspect ratio is simply width versus the height. Okay, so ratio of width and height. So for example, when you talk about the YouTube video that we see, like here if you see, this is the YouTube video. Okay, so the aspect ratio of this one is 16:9. You can clearly see the width is more than the height, correct? So width ratio height is 16:9. Okay, now for different resolutions also this aspect ratio remains the same. When we talk about like shorts or reels, which is like vertical video, for that the height is more than the width. So in that case aspect ratio is 9:16. And like this we have many more aspect ratios, but when we talk about YouTube, mostly these two are most famous. This is for the long video and this is for the shorts or reels. Now an important point is YouTube or any other platform like Netflix or Amazon Prime, they do not create separate versions for every device shape. So they do not create mobile version, tab version, laptop version, TV version. Because if we do this on server side, then we have to store all of that again to S3, and then you can imagine so much of storage would be required. So if the backend or the server is not doing this, then how is this managed? So basically the role of backend here is to keep the original aspect ratio of the video. So if the user uploaded a long video, that should be in 16:9, this one, and that is maintained even when we are creating separate resolutions while downsampling. Like we are creating 144p, 360p, 720p, 1080p, correct? So in all of those the aspect ratio is maintained as the original video. Okay, so the backend is simply creating different resolutions and bit rates, but the aspect ratio for each of those is kept same as the original video. Now it's a client who will adapt how to display it, because client knows the platform, whether it's like the mobile application or we are using the smart television. So it's a role of client to adapt that. Backend is not generating any separate video based on the device shape. The aspect ratio is maintained in all of the resolutions. So it's a role of client who has to adapt based on the device. Now how does the client manage that? We don't need to know that in detail, but just to give you brief, it will be something like this. The client will basically read the video width and height from the metadata. Like for example, if the original video was 16:9, which is the long video type, correct? Say it was like 1920 by 1080. So the backend will generate different resolutions. Like for 360p, it will be 640 into 360. This represents the width and this represents the height. And similarly for 720p, you have 1280 into 720, and 1080 is 1920 into 1080. Okay, but clearly you can see for all of the resolutions the aspect ratio is remaining the same as the original one, correct? So the client will get the video width and height like this way from the metadata, and client already knows the screen size and screen orientation. So say user is using the mobile phone, okay, so client already knows whether it's in the vertical or the horizontal position, correct? So based on that, it already knows the screen size and screen orientation. Then based on all of these factors, it will decide whether to show the full screen, add black bars on the side, crop slightly, or zoom to fill. Okay, so this is all handled at the client side, correct? So we don't need to worry about this, because here we are talking about the system design in terms of like backend, how to scale things and how to manage things, what are the components. So you don't need to know this completely, but I just gave you an idea so that it gives you some clarity. Okay, how does this actually happen? So the main point to remember is, like, we created different resolutions on the backend side using our video processing microservice, but we are not creating any different videos based on the size of the device. Okay, The aspect ratio in all of the resolutions is kept same as the original video, and it's a role of client to show it according to the device type. Okay, so going back to our original diagram here, let me add one more thing. With the database, we also use the cache in order to increase the speed overall, because the things which we read from database, so we can use the famous cache options like the Redis cache. Okay, so basically using the cache, if we have the cache hit, overall the latency can be decreased, right? So I've created all these arrows here, and similarly, as we already know, the video upload service interacts with S3. So let me also add an arrow from video processing service to the S3, because it will download the video from this S3, correct? And in the beginning, client uploaded the video to S3, so we have added an arrow here. So client uploads the video to S3. Here let me also connect the video upload service to S3, because it will interact with the S3 for, you can say, generating the pre-signed URLs to get the location where the chunks needs to be stored in the S3, correct? But the upload will be done by the client side. Okay, all right, so with this we have covered our first major functional requirement, which was like user should be able to upload the video. So user is able to upload the video using the video upload service and this video processing service, which performs the asynchronous task in the background, where it has created multiple different resolutions of the original video, and alongside that it has done a lot of other things like segmenter, thumbnail generator, and copyright check. We also discussed the segmenter will create small segments which will be different from the chunks that were created by the client, because while uploading, the size of the chunk can be around 10 MB, which is also decided by the backend. Like the video upload service decided say 10 MB as the size of the chunk, but when we talk about the segmenter in the video processing service, the segments are kept very small in size. It can be, you can say, 1 to 5 MB, so that the end user is able to fetch the segment very quickly, because we want least amount of latency while the user is watching the video, correct? So after this, our second major functional requirement was that the user should be able to view the videos. Now of course the videos are present in the file storage, which is S3. So let's say the client is in India and the Amazon S3 storage was present in, say, in US. So as you know, India and US are quite far away from each other. So if the client is trying to fetch the video segment from S3, it will take a lot of time, because the request has to travel a lot of distance, correct? But our functional requirement was that the client should be able to view the videos, and non-functional requirement was that there should be least amount of latency. So it's a very generic kind of problem when we talk about images and videos or the static assets, and this problem is resolved by another component which is called as CDN. Now CDN stands for Content Delivery Network, and if you want to know in detail about CDN, you can refer to this video of mine where we have discussed about CDN in detail. But in summary, if I have to tell you, basically the problem that I told you, like the client can be far away from the S3 storage, this is resolved using the CDN, because CDN is like distributed set of servers which are present across the globe. Okay, so you can imagine like millions of servers which are present there all over the world, and they are specialized for keeping the static assets like images, videos, audios, and much more. So we don't keep any dynamic content in the CDN, we keep the static asset. So all of the famous videos which are getting viral, those will be present in the CDN layer. And in our example, client was in India, so the video will be served from the nearest CDN available, which might be in Mumbai only. Okay, so now you can clearly see the distance between the client and the CDN which has that segment of the video is quite small, and hence the latency will be very low. Again, in order to understand in detail about CDN, you can refer to this video of mine and you'll get more clarity about it. Now let's try to understand the complete flow, like user has clicked a video, wants to watch a video, how that process happens. Let's try to understand that. Okay, so the first step, as we said, so then from the client side an API request will be made. So say it's a get API watch, and we have passed the video ID in it. So this request will be sent to the backend server from the client. Now the step 2 would be the backend server will return the metadata and the manifest file that we talked about. So it will contain the metadata related to video and the manifest file, and in the manifest file we have all the available resolutions for that video, like it can be 144p, 360p, 720p, 1080p, or even 4K. And alongside that, it also contains the URLs of the video chunks. Here these chunks represents the segments that were created by the segmenter module inside the video processing microservice, right? We said like the segments will be very small in size, like 1 to 5 MB. Now basically the URLs of the video segments will be the CDN URL. Okay, so here CDN is the new component, correct? Now client does not know the URL for CDN. Client simply makes a request to the backend, and the backend server will return the manifest which will contain all the resolutions for that video. Alongside that, the URLs of the segments of that video which was created by the segmenter of this video processing service, and those URLs will be of CDN. Why CDN and why not S3? Because as I said, S3 storage might be quite far away from the end user. We want least amount of latency, and the role of CDN is that CDN is, you can imagine, huge amount of servers which are present across the world, and they are specialized for keeping the static assets like images, videos, etc. So the backend is returning the client the URL of the video segments, and those URLs are of the CDN layer. Okay, now in order to understand in a better way, let's see an example. When we say the URLs of the video segments, it would look something like this. You can clearly see the domain contains the CDN URL, cdn.youtube.com. Okay, and after that we have the video ID, then the resolution, and then the segment ID, because the video processing layer created small segments of the resolution that were created, correct? So like this is for segment 1, this is for segment 2. Now after this, the step 3 would be, as client already has the manifest file which contains all the resolutions, correct? So the client will choose the resolution, and it will choose the resolution can be something like this: 144p, 240, 360, 480. So because it's kind of auto setting, so the client will choose which resolution to play, and it will choose based on the internet speed, screen size, CPU, buffer health. So all the factors clients checks, and based on that client will pick one particular resolution. Say client picks 720p. Now as the client has selected a resolution, say 720p, so the next step would be client would request the first chunk because it already has these URLs present, correct? Now after this, the step 4 would be client would request the first segment of the video because client already has these URLs, correct? And it has selected a particular resolution as well. So it will hit an API, say it's a get API, and it already has the URL from the backend response, correct? So it will simply hit this. Now clearly you can see client had these URLs and it had the resolution. So based on whatever resolution client picked, it can put that resolution in the API. Okay, so it's a good point to notice here, because as we said, the bandwidth or the network on client side may keep on changing. Say earlier user was using like Wi-Fi and 720p was totally fine, and suddenly the Wi-Fi was not working and user switched to the mobile data, which might not be that quick, correct? So now client will try to automatically switch to a lower resolution, say 360p or 144p, so that at least the user or the client can able to watch the video on lower resolution, correct? It's much better than watching nothing, right? So now client does not need to make an API call again to backend because it already has this URL, and it can simply replace the resolution here. So instead of calling this, it can simply replace 720p to and like 360p here, and rest of the URLs remains the same. So it can fetch that segment from CDN from the same URL, just replacing the resolution. Now after this, step 5 would be that the DNS will route user to the nearest CDN edge, because the URL that we hit was the CDN URL. Okay, So basically what DNS will do is like it will route to the nearest CDN edge. It's like millions of POP edge servers which are present all over the world. So DNS will route to the nearest CDN edge. Now, if you want to know about the DNS, you can refer to this video where I have discussed about the basics of system design in complete detail. So you will get the complete understanding how the networking side of things work for the basics of system design. Okay, so as we said, like in our case the user was in India and we assume that CDN server was present in Mumbai, so the DNS will route to the Mumbai CDN node IP. Now, as I mentioned earlier, CDN is specialized for caching, you can say, the static assets like images, videos. So when the request goes to the CDN, it will check whether that segment of the video that was asked by the user, correct, is that present in CDN or not. So just in case it is present in CDN, that's wonderful. It's a cache hit, correct. So you will get the segment of the video directly from the CDN itself. So clearly it means the client got the CDN URLs from the backend server, correct? And then client hit those URL. So that hit to the CDN and CDN is checking whether those segments are present in CDN or not. If present, that is cache hit. And in that scenario, you will get the segment directly from the CDN. Okay. So that is the case of cache hit, right? And in this case latency will be very low because you are getting the segment of the video directly from the cache, and that too from very nearby place, correct? You were in India and the CDN is also in Mumbai, so the request has to travel very less amount of distance, and then you are getting the data from cache which is already very quick. So in this cache hit case the latency will be very low, so the end user will be able to see the video very quickly without any buffering. So we discussed about the positive case. Let's also now talk about the case where the segment is not present in the cache, so it will be a cache miss. So in that case what will happen is, because client asked from CDN but the segment of the video was not present in CDN, what CDN will do is it will fetch that segment of video from the S3, because all the videos are stored in the Amazon S3 file storage, and now CDN has those video segments, so it will provide those video segments to the client and it will also keep those in the CDN, so that if next time any other client or the same client asks for those segments, it can be served directly from CDN without going to the S3 storage. Because if you go from CDN to S3, it will take more time, correct? And user has to wait, and we want least amount of latency. So once the CDN gets the video segments, those will be stored in CDN, and next time if the same segments are asked for, those can be returned directly from the CDN layer. Now in this case, as the CDN got the segments from the S3 and it will store it in CDN, as well as it will provide it to the client. Now that client has this video segment available, so the next step would be client would start playing the video segment. So user is able to see that first video segment, because the logic is you don't want to get the complete video in one go. If you try to do that, of course the latency would increase by a lot and the user has to wait to watch the video. We don't want buffering, correct? So we picked like very small segment in the beginning, like 1 to 5 MB, which will take very minimal time, so the client can watch the starting segment, and during that time when the user is watching the first segment, the client will request the further segments like segment 2, segment 3, segment 4. It will pick those from the CDN. The same logic that we did here. If it's a cache hit, you directly get the segment from the CDN. If it's a cache miss, the CDN will get it from the S3 storage. It will give to the client, and at the same time it will store in CDN also, so that if the same request comes next time, it can be served directly from CDN. Okay. So you can clearly see we are doing the pre-fetching so that there is least amount of latency. Now apart from this, as we discussed earlier about the adaptive bit rate, the network can keep on changing on the client side. So based on that, it's a client's responsibility to keep on switching the resolution, because it already has the resolutions from the manifest file that it received from the backend, correct? And it also has the segment URLs, so it can simply replace the resolution here. It already has the CDN URL, so based on that it can fetch the segment resolution as per the requirement and then play that resolution, because the bandwidth is low. And again, if the bandwidth or the network increases, then it can fetch the higher resolution video segments from the CDN and play that for the end user. Alright, so with this we have completed our second major functional requirement, which was related to that user is able to view the video, and the non-functional requirement was there is least amount of latency in that. Correct. So let me add some arrows here to represent the flow for the second major functional requirement, and let me put that with the green color here. So first, client will ask the backend servers for basically getting the details related to the video. So from backend it will get the response which will contain the video metadata, and also it will get the manifest file. Correct. So inside the manifest file all the information related to the video will be present, like all the different resolutions and also the URLs of the CDN from which it can get the video segments. Correct. So once the client has that information, client will connect with the CDN to get the video segments. Correct. So in case the CDN contains that video segment, it will be directly returned to the client from the CDN only. But just in case that video segment is not present in CDN, CDN will get that video segment from the S3, because all the video content is actually stored in the S3. Correct. And S3 will return that video segment to the CDN. Now CDN will give it to the client, and at the same time CDN will store that video segment in it, so that if next time a request comes for the same segment, it can be directly returned from the CDN, because we want least amount of latency. Correct. So with this we have covered both of our major functional requirements. User is able to upload the file, and user is also able to view the video with least amount of latency. Alright, now let's discuss about like, comment, service. Although it's not a major functional requirement, but still let's discuss about it because I feel it's quite interesting and it might help you in some other system design interview round as well. So when we talk about like, comment, service, there are multiple things which come into picture. Let's see why. So first one is the SQL database. And why is this required? Because single user can like the video or dislike the video only once. Basically you can increase the like count of the video by only one. So if you like once, it shows that you have already liked. You can unlike it and again like it, but by maximum you are increasing the like count of the video by only one. So using this SQL database, we will maintain this part that user has already liked or disliked the video, and through this we will make sure that user cannot increase the like count of the video by more than one. We will see later in this video how we will do that, but for now let's move ahead. Okay. After that we have Redis. So Redis is used here as a fast counter for UI. Okay, on the UI the user can see the like count. Correct. So Redis is used for that. Basically the point is you will get a lot of likes because there are so many videos, right? And say one of the videos becomes viral or becomes famous. Okay, so there will be a lot of likes coming for that video, and you cannot keep on updating the likes in the database one by one, because if you do that your database will go down. So you have to always remember this point. If there are a lot of write operations or update operations happening, then make sure you are not writing this kind of logic that for each operation you are performing the update or insert operation on DB. If you're doing this, it is not scalable. Your database will go down. So for that we are doing this stuff here. First we are maintaining a Redis counter. Okay, Redis is already a distributed system and it can handle that kind of load. So basically you can use the INCR operator provided by the Redis, and through this you can increment the count. One more good part of Redis is that as it is single threaded, so there is no issue related to concurrency. Otherwise when we talk about database, we have to take care of concurrency. Correct. So we would need to apply the locks, and by using the Redis we don't need to do that as it is single threaded. So this INCR is atomic. Okay, and after that we will use Kafka. You can clearly see here in Kafka we have published events like video liked. You will also have video unliked if you are showing the unlike counts on your platform, and similarly you will have comment added for the comment part. Firstly we are talking about the like part. Correct. So video liked is the event which is published to Kafka. So we are using Kafka here, correct? So same, we have mentioned it here. We are using Kafka here. Now, why are we using Kafka? Because the aggregator service or job, it will consume from Kafka. So aggregator will consume video liked event and it will perform the aggregations, and after performing the aggregations it will push that in the database. Now why in database? We already have the Redis, correct, to maintain the count. Why do we have to put this in database? Because Redis is in memory. What if Redis crashes? You will lose the like count. So we need to make sure that we are adding that information in the database as well. Of course, we cannot do like for every like we are simply inserting or updating the database. That is not scalable. But yes, after doing the aggregations, what aggregator can do is like it can push like all the aggregations that it has done over a while in one go in the database. So for example, you got like 20 likes. So you are not doing 20 update operations on database. This aggregator will take care of these 20 likes, and simply with one update or insert operation it will push that in the database. So till now I have explained this part. Okay, the core idea is you cannot directly update main database counter for every like. So this is a very important point and you should remember this, not just for this like service but in generic as well, because whenever you are asked a system design interview question, you can get any question, right? But whenever you get this kind of situation that there are so many writes happening, okay, you need to make sure that your logic is not like that you are updating your database for each and every write, because your database will die with that. This thing is not scalable. Okay, so you need to have something like Kafka out there and then perform the aggregations or any logic, and you need to make sure you are doing the batch processing in database and not doing for each and every operation out there. Okay, another point was we are not doing everything using database because as we said writes are difficult. At the same time, if you read everything from the DB, it will also not scale, because likes is something that you will have to show for each of the video to all of the users, correct? So you can't do like performing write and read operations on the DB every time, right? So we have Redis here for fast counter for UI for the read operations, and then to perform the writes we have Kafka and the aggregator. Okay, and another point is aggregator will update the database as well, because we cannot only rely on Redis, because if Redis crashes then we will lose the like count as it is in memory. So in order to understand this in more detail, let's see the complete flow, what happens when user likes the video. So the step 1 is user has clicked on the like button. So what will happen is from the client we will hit the like API. So something like this, we have the post API like, and inside the body we will pass the information like what is the user ID, what is the video ID. Remember we generated the video ID using the video upload service, correct? Now after this, as we mentioned above, we will have a SQL database because a user can increase the like count of video by only one, correct? So we need to make sure that we have that logic. So in the entity we have video likes, inside this we have user ID, video ID, and the status can be liked, none, or if you even provide like dislike kind of feature. Okay, so here as we need to make sure that user can increase the count only by once, so we have made a combination of user ID and video ID, that is the composite key as the unique. Okay, so the combination of this should remain unique. Next we need to update our table, correct? So we can do something like this: update video likes table. This was our table, correct? And we are setting status to like, or for the first time if we are doing, we can insert into this table and we can put the user ID, video ID, and status as like. By doing this we are guaranteeing that user can like only once and there is no double counting. Now after this, next step would be publishing the event to Kafka. So we will publish video liked event to Kafka. We will pass the user ID, video ID. Now why Kafka? Because as I said, first thing, when you have the case where you have a lot of write operations coming, so you make sure that you do not update your database one by one, because that is not scalable. So in that case, we generally use Kafka. So Kafka is a message queue and it is also durable, because the retention period in Kafka is like 7 to 30 days, which you can configure. So it makes sure that nothing is lost, that event will stay in Kafka. Even if Redis crashes, you still have that event in Kafka and the aggregator can consume that event, and based on that it can calculate the results and put that in database. So here aggregator is the consumer of this event from Kafka. Even if the aggregator crashes, it's totally fine because that event will stay in Kafka for like many days. So event is safely stored in Kafka and consumers can consume that event on their own pace. Okay, and this retention period of like 7 to 30 days, it is enough. Like even if you have multiple failures, you can still fetch this again and perform your task. How does that happen? Using the offsets. But we are not going to talk about Kafka in detail here. If you want me to cover Kafka in detail, put that in the comment section. I'll create a separate video on that. Now we have pushed in Kafka, but at the same time we have to show the things to UI for our read operations on the like count. So for that, what we will do is like we will update our Redis counter. You remember I mentioned that we will use SQL, Redis, Kafka. We have talked about SQL and Kafka, so we are talking about Redis now, because through this the UI will fetch the like count. Okay, so we will update the Redis here. So it will use the incr operation which is provided by Redis, and as I told you earlier, this is atomic operation. So as Redis is single threaded for this kind of operation, okay, so it also takes care of concurrency. So we will use incr, this is the key and this is the like count. So we will use incr and like this we will increase the count. Now Redis is used here because it is very fast, and on UI we need to update the like counts, and Redis can handle huge amount of load for this kind of operations. As we have updated the count here, the UI or the front end will get the count from Redis, and then we can display that on the UI. So as we have updated the Redis count here, now client will get the count from Redis and it can refresh the UI, and on UI user will be able to see the like count. So till now in these 6 steps we have talked about SQL, Redis, Kafka. Now we are left with aggregator. So the question comes, why do we need aggregator? So the answer of that is basically we need aggregator as Redis is in memory, and if Redis crashes it can lose the data. We are using Redis only to display the count on the UI, but it is not giving us the persistent storage. So for that we have inserted the events in Kafka, and now aggregator will consume those events from Kafka, perform the aggregations, and then push that to the database so that the like count is durable, it is persisted in database. So basically the step 7 would be aggregator consumes the event from Kafka. And what aggregator service will do is like for each of the event, if it is like, then you increase the count. If it is unlike, you decrease the count. Say for example there were 20 events for a video and all of those were video liked, so it will increase the count by 20. Now the step 8 would be this aggregator will update the database. Okay, it has already performed its aggregations. Now it will simply update the video stats table. So it would be something like update video stats, set like count equal to like count plus whatever the aggregated value it has calculated. So it will not do for each and every event. Like I said, say for example there were 20 like events and it has increased the counter by 20, so it will simply do like counter plus 20. Okay, where video ID is this. So you can clearly see that we are not performing this update operation on database 20 times. We are just doing it once after we have performed all the aggregations. So we can have some threshold like after every n seconds or after every n events, whatever happens, so aggregations will happen and that will be pushed to database in one go. So it's kind of a batch update. Okay, so say there were 100 events, so you are not doing update operation 100 times, you will just do once. Okay, and then step 9, just in case Redis crashes, then it can simply pick the count from the database, because in database we have updated the value and database is acting as the persistent storage. Okay, so we can use any SQL or NoSQL database here, and from that Redis can pick the count. Okay, so as there were multiple components in this like service, let's see this summary. So first thing, like a user can increase count only once. How do we make a check of that? Using our SQL database. We kept a composite key of user ID and video ID as unique. Okay, so it makes sure that a user can like video only once. Then talking about the final count, that will be calculated by the aggregator and then it will be present in the database. Okay, the aggregator will update the database. Next, if we talk about the fast UI count, or from where the UI is showing the count, that will happen through Redis, because we don't want to put that much load on the database, so we are simply picking that count from the Redis. And if we want to check the event history, then that we can do from Kafka. So that's why in like service we require SQL, aggregator, Redis and Kafka. Now, as I told you here, that the aggregator will perform the aggregations and then it will update the database once. So let me show an example to you through which you'll get more clarity. So for example, in Kafka we had these three events: video liked, video liked, video liked, and for the same video. Okay, so now aggregator will consume from Kafka. So what aggregator will keep is like, this is the video ID and it has increased the count by 3, so it has done plus 3, so it has performed its aggregations, right? So for that particular video ID, now we have made the count plus 3. Okay, so after every n seconds or after every n events, we can keep that threshold, whatever comes first. Say we have kept like n equal to 10 here, so after every 10 seconds, so what we are doing here is like, we are updating the table here and we have set the like count equal to like count plus 3. Clearly you can see we have updated with the count. It's not like we are updating the database for each and every event. For all the events, aggregator has performed the aggregations and we have performed the update operation only once. Okay, so this was an example of aggregation. So with this we have covered the flow for like service. So we saw the flow for like. Now similarly, let's see the flow for comment. All right, so this is for comment flow. The first step would be, say client has commented on the video, so from the client side we will make an API request to the server. Okay, so it will be a post request. In the URL we have videos, then video ID, and then comments is the endpoint. Of course it will contain the JWT in the headers so that we can do the authentication, and inside the body we will have the text like whatever comment was made on the video. Now next step would be, of course, as client has made an API call, it will go to API gateway. API gateway will verify the JWT token. If you want to know more about like what is a gateway, you can refer to this video. And if you want to know in detail about what is a JWT token authentication, how does that work, refer to these videos. Okay, now the role of API gateway is also to check the rate limiting, and it will forward the request to the correct microservice. As we are talking about the comment, so it will forward this request to the comment microservice. Okay, now basically what we will do is like, we will first check if the video exists, because we have the video ID here, so we'll check if there is any video with this ID or not. Then we will do further checks like whether the video is commentable or not, because the person who has uploaded the video can set these kind of settings that no one can comment on the video. So of course, I mean, on UI also you have those kind of checks that comment part is blocked, but you cannot just rely on the client side, because someone can make this API directly as well, right? So you need to have all these checks on backend as well. Okay, so we will check first, and we will check some of the other things like what is the text length of the comment, any spam rules, the rules we have put in the cache, we'll simply check those. Now here you can see in the comment flow, we have not checked the things which we checked for like flow, because in like there was a restriction that a user can like a video only once, but there is no restriction on comment. A person can make multiple comments to a video. Okay, so after step 1, in step 2 we will write to the comment database. So comments is the name of the table, and inside that we have comment ID, video ID, user ID, text, which means what was the comment. Then we also have the parent comment ID here. Okay, why do we have this? Because in some of the places you get an option that you can reply to a comment. Okay, so the one to which you are replying becomes your parent, right? So based on that you can have hierarchy in the comments. Okay, next we have created at and status, which is visible or not visible. So as I told you earlier, you can see I am discussing some of the APIs and the entities in their schema here when we are discussing about the component. Okay, because I thought if I tell all of these in the beginning it might become a bit confusing, but now that we are talking about the comment service, it makes more sense. And another thing here is like, number of comments on a video are generally not that much. When we talked about the like count, you get a lot of likes on the video, but as compared to that, the number of comments that you get are not that high. Okay, so that's why here we are updating the database directly. But here, as we are inserting in database, if some of the video becomes really viral, there may be a case that you get a lot of comments on that video and that becomes a trending video, correct? So if you are inserting in database, so say we were using SQL, then you may have to do sharding in the SQL. And in case we do that, the sharding key would be the video ID. Why are we doing sharding based on the video ID? Because the reads will be based on the video only. So basically when you open a video, you see comments of that video, correct? So we would prefer sharding key as video ID. Now, if you want to know more about the concepts like sharding and database, when to use which database, you can refer to this video of mine. I have talked about all of the databases in this video in very much detail, and if you watch this, you'll get a lot of clarity about databases, what are the types of databases, when to use which one, and all such concepts like sharding, normalization, joins, different type of DBs, everything. Okay, anyways, coming back to our topic, so the next step would be our comment service will emit comment edit event to Kafka. So it will be comment edit, it will contain the comment ID, video ID, user ID. So we added that in the diagram here, correct? You can see comment edit. So from here we have emitted the event to Kafka, right? So we are doing the same thing here. And then the step 4 would be like we did for like service, we will update the comment count in the Redis using that incr operator, because on UI we need to show like how many comments are there, correct? And again, similar to what we did for like flow, when we pushed it to the Kafka, and there will be a count aggregator that will consume this event comment edit from the Kafka, and then it will perform the aggregations, and then it will do the update operation in the database, which will be a kind of batch update. So like there were like 10 comments, we will not update database 10 times for the count. The aggregator will perform the aggregations, and simply we will do the update count operation only once in the database. Next, the step 5 would be notifications. We need to notify the user that someone has commented to the video. So basically, as we have this event comment added in Kafka, the notification service will be one of the consumers of that. We said aggregator will be a consumer. Similarly, the notification service will also be a consumer to this comment added event, and then based on that it will notify the video owner, and also it will notify the parent comment owner. In case of reply, we will take care of the replies using this parent comment ID. So in case someone has replied to your comment, then that person can also be notified. And notification service was part of our diagram, if you see here. So it will also consume from the Kafka, it will consume this event comment edit, and based on that it will perform the action, right? So clearly you can see Kafka is playing a big role in this system here, and using Kafka we are doing the communications between different microservice, correct? So let me add an arrow here because the notification service is reading from Kafka, right? So I've added this arrow, so it will consume this comment edit event from Kafka and then perform its action. Now for like comment service as well, let me add one more layer here, which is the aggregator. So here is the aggregator, and it will also listen to the events like video liked and comment added from the Kafka, and based on that it will perform the aggregations, and after that it will update the database. So it's difficult to add an arrow here, but yeah, from the aggregator we will update the database. I can do something like this. From here this arrow comes, right, and this will update the database, right? So going back to our flow where we were mentioning the step 5. So till now we have reached to the notification step. Next, talking about one more step, you might have seen like YouTube detects if there is anything wrong in a comment, correct? So for that we will have the spam detectors, toxicity classifier, which will identify if there are some wrong words used in a comment. Okay, and how does this happen? These also will consume from Kafka this event. Okay, this event was consumed by aggregator, this was also consumed by notification service, and these components will also consume this event. Okay, these can operate on machine learning or any algorithms that you define, and based on that it will identify if there is something wrong in the comment. And if the comment is bad, what it can do is like it will update the status in the comments DB as hidden, right? We had the status field here in the database schema, correct? In the comments table we had this status field, so if they find out something wrong in the comment, they will just update the status as hidden, so that particular comment which had something bad in it will not be visible to the other users. So you can clearly see we have used the status here, which was part of the schema of the comments table, right? This one. So we can also use this in case of deletion. If someone deletes a comment, then we can mark the status as deleted, and when we are showing all the comments of a video, we can use this status field from this table, and based on that we can identify what to show and what not to show. One more thing that we can do in the comment service is, like, sometimes some of the videos become really trending or famous and a lot of people keep on coming back to that video. What we can do is, like, we can cache the top comments of that video so that we don't need to fetch that from database every time. We can show those top comments by using the cache, and in case user clicks on like show all comments or show other comments, you can fetch that information from DB. But just in case you need to just show the top comments, you can do that from the cache directly instead of querying the database. All right, so with this we have talked about both the like and the comment flow in the like comment service. Right now, if we talk about the search service, we will basically use the elastic search here, because that is generally used when we talk about the search operations. We are not going to talk about elastic search or how search happens in this video, but if you want to know more about it, you can refer to this video of mine. I've discussed about the elastic search in this video, and you will also get an idea how it works and when to use this. Okay, so you can refer to this video. So we are not going to talk about notification service in detail in this video. If you want me to cover notification service, put that in comment section. I'll create a separate video. But just to give you a brief summary, like, we use FCM and APN for notifications. FCM is used for Android devices. The full form is Firebase Cloud Messaging, and APN is used for iPhones or Apple devices, and the full form is Apple Push Notifications. Okay, and now coming to recommendation service, again we will not cover this in this video because it is out of scope for this video, but generally recommendation engines would use something like the machine learning or any other algorithms that you have, and based on that it will recommend you some of the videos. Okay, so overall this is the complete diagram for designing YouTube for the features that we mentioned. The major features were like user can upload the video and user can view the video with least amount of latency, you can say. Okay, and then we also talked about another requirement which was not that major. It was like the like and the comment flow. Okay, I hope you got the clarity about how to design a system like YouTube. If you want me to make video on some specific topic, add a comment for that as well. Okay, all right, then this is Mohit Chabda signing off. Subscribe to the channel and thanks for watching.